Welcome back to Fat Mama Physics. In this video, we are going to talk more about complex algebra solutions on how to deal with equations. This is part 2 of 4.3, which is on what happens if you have variables on both sides of the equation. Then what do you do? More specifically, this part of this video, part 2, I'm going to be dealing with applying the distributive property, which hopefully you should have learned back in your polynomials unit. But you haven't, hopefully you'll catch up on it. It's not too bad. And this is what I've been alluding to in the previous video about the board game King of New York, which you distribute the damage to all your monsters. But anyways, the idea is that when you do distributive property, you have to distribute whatever coefficient is in front of the brackets to everything inside the brackets. You have to be fair to all your terms. You have to be fair to all your terms. You have to be fair to all your terms. Okay, hopefully you got that. So let's get down to business. There are 4 questions, meaning I'm going to do 2, you're going to do 2, okay? Let's see, I'm going to zoom in. I'm going to do A, you're going to do B. I'm going to do C, you do D, okay? I'm going to circle the ones that I am doing in green, okay? Oh, wait, sure, I guess so. I changed my mind to purple because just to make it coincide with the previous video. Okay, so let's do this one. I have 3 in brackets a minus 2 plus 2 equals to 2a. So you might be thinking, well, if I want to get the a, can't I just divide 3 to everything? You could. It's not wrong. It will just give you more trouble because you'll end up with fractions, and that's not fun. So if you don't want to deal with fractions, the easiest way to get the a outside the bracket, which is what you want the a outside the bracket so you can combine it with the other a's in the rest of the equation. So let's get the a out of the brackets by using distributive property. So here I have a 3. And what it means to distribute the 3 is I have to distribute the 3 to the a. I have to also distribute the 3 to the 2 as well. And you're thinking, it's just a dumb rule. How does it work? And why does it work? Here, let me give you a quick example. Okay, I'll erase this in a moment. So imagine I know what a is. Imagine a is, I don't know, 4. Okay, 4 minus 2. All right, so let's figure out this equation here. Since you know what a is, 4 minus 2 is 2, and 2 times 3 is equal to 6. So let's apply distributive property, assuming we don't know what it was 4. So I get 3 times 4 is 12, and let's distribute the 3 to the 2 as well. 3 times 2 gives me 6. 12 minus 6 also gives me 6. So the distributive property works, okay? It's not just some random rule you have to follow. It's very mathematical, and it makes very logical sense. So what happens here is I have 3, then multiply by the a. That's what it means to distribute it. I take the 3, I multiply it by that term, okay? It's the terms that are inside here. So 3 times a minus 3 times 2, which is 6. Actually, I'll write this out so you can see. Okay, so after I distribute it, then I can write the rest of my equation down. Notice I am only distributing the 3 only to whatever's inside the brackets, nothing outside of the brackets. So let's say, and I mentioned that you're distributing it to every single term, right? So then you might be wondering, oh, what happens if I have, I don't know, like minus 2a or something? Then what would that look like? Same thing. I take the 3 and I multiply that term. 3 times negative 2a is 3 times 2 gives me 6, and I have a negative there. The a stays there, okay? The 3 then multiplies this negative 2, then 3 times negative 2 gives me negative 6. So that's what happens if you, say, have a more complex term instead of just a single variable, okay? Haha, you're going to need to deal with that in the next question. So let's simplify this a little bit. I have 3a, okay, minus 6 plus 2 equals to 2a. This is very nice because I should get the a's together, but why not? I could do this first. Because I have negative 6 plus 2, right? I can just combine the 2, and that will make my life a lot easier. Then if I do that, I get negative 4 because minus 6 plus 2 gives us minus 4 equals to 2a. All right. now what I could do is I could just move the 3a to the other side, but I like to keep things positive, so I'm just going to subtract 2a on both sides, and which then gives me 3a minus 2a, which gives me 1a minus 4 is equal to, don't forget, don't leave the other side blank. If it's blank, it means is probably 0. And then you can see, okay, well, it's obviously going to be 4, but why? I'm going to add 4 to both sides of my equation, gets rid of this one, and then a is then equal to 4. Okay, so there we go. That is applying the distributive property to when you have to solve algebraic equations when variables on both sides of the equation. Guess what? Now is your time to try B. Good time to pause the video. Okay, and like I said, if it's a question you're doing, I'm going to go over a little bit faster. So again, I'm going to apply the distributive property here so that I don't have to deal with fractions. Negative 2 times 2c is negative 4 times 2 is going to give me negative 8. Okay, and don't forget the c, I need that as well. Negative 4 times positive 1 is going to give me negative 4. Don't forget the negatives. This is equal to 5 times 1 is 5. And then 5 times negative c, I always think of that, or just have the negative. Don't forget the negative there. 5 times c gives me 5c, just like that. Okay? And whenever you're distributing like this, the numbers always combine with the numbers, so you don't have to think about, oh, the 4 goes to 2 and to the c. No, that only happens one time for the term, but must be applied throughout the terms. So now I want to get the c's together, and I have a bigger negative on this side, so I'm going to add positive 8c. I'm going to add 8c to both sides, so that when I calculate everything, I get, don't forget the negative 4 here, don't forget, even if you take the negative 8c away, that doesn't make that 4 positive. You still have to keep that negative sign in front of the 4. So be careful of that one. And then on the other side, I have 5 minus 5c plus 8c is going to give me a total of 3c's. So plus 3c. Okay, good time to peel the onion. I'm going to get rid of the 5 here by subtracting 5 on both sides of my equation. Minus 4 minus 5 gives me minus 9 is equal to 3c. Then I can divide both sides by 3. This is peeling the inside of my onion, and that gets rid of that c. I gets rid of that 3, so I get c is equal to negative 9 divided by 3, negative 3. Next up, we have c. Hey, this is my question, so I get to go over this one. Okay, and this time looks like we have some decimals. Decimals are just numbers. Be not afraid of decimals. And again, we're going to need to use the distributive property, but this time we have 0.1. 0.1. So again, the number multiplies the number, leaves a variable alone, but I have to do that to every term inside my brackets. So as well as the 10 as well. 0.1 times 5, if you put in your calculator, or you can calculate very quickly, is going to give you 0.5 W. 0.1 times 10, or don't forget the minus sign, that's going to give me 1. Ooh, we like it when numbers work out. Minus 0.5, we keep that, okay? And then equals W plus 0.5. So don't forget everything else on the other side. Okay, so again, we want to get the W's together, but there's a few things we can simplify. For example, this over here, minus 1 and minus 0.5 is going to give us minus 1.5 if we combine them together, equals W plus 0.5. Okay, and to get my W's together, I have to subtract it on either side because they're positives. And I'm going to subtract the lesser value so I can end up with a positive value instead. Okay, so here I subtract 0.5 and I get rid of it. Don't forget this negative 1.5 stays. That negative in front of the 1.5 has to stay there. It doesn't disappear after I take away the 0.5 W. So this is equal to 1 W minus 0.5 of a W. What is 1 minus 0.5? 0.5. 0.5 W plus 0.5. Lots of 0.5s, hey? All right, next up, what we need to do is, again, peel the onion. So getting rid of the outside terms, which is the 0.5 beside the w, beside this guy over here. So I'm going to subtract 0.5 on both sides of my equation. I'm going to get 1.5, negative 1.5 minus another 0.5 is going to give me negative 2 is equal to 0.5w. Last step, okay, isolating for w, I need to divide both sides by 0.5, okay? Dividing 0.5 is exactly the same as multiplying by 2, if you're wondering. So negative 2 times 2, or divided by 0.5, is actually going to give me negative 4, okay? So I have w left, negative 2 divided by 0.5, that's going to give me negative 4. Bam, that's my solution there. Okay, hey, this next one is yours. All right, so you're gonna try D. Good time to pause the video. All right, so I am gonna go over this one. Ooh, this one's a little tricky. Oh, I haven't started. Oh ho ho. So yeah, this time you have an X as to distribute as well as a 2. So this guy's got to distribute itself here, and it's got to distribute itself there. Same thing with this over here. Oh, you know what? I designed this question so it'll look very easy. Because you might be thinking, oh, I just divide 2 on both sides of the equation. It'll make it easier. Ha 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 ha. Sure, why not? Let's do it. Okay, so when you're doing this, you might have just distributed this. And it would have worked. You could have calculated it, no problem. But this is a cool thing you can do. Take a look. You have 2x times this thing in brackets. You have 2 times this other thing in brackets. And that's it. There's a factor of 2 on both sides that you can divide it out. So I could have just done this. I divide both sides by 2 first. Make my life easier, right? So I can get rid of this 2, get rid of this 2, get rid of this 2, get rid of this 2. Okay? And that's going to give me x, and then in brackets 1 minus x is equal to, in brackets, well, since I got rid of the 2 here, I don't have to leave the other side in brackets anymore, x minus 3, okay? Now, that was a cool thing to do. It's kind of like a shortcut, but it's just to make your life easier. You have to be very careful with that, because if, for example, on this other side, let me use a different color. If I had, say, minus 1 on the other side, okay, then what you had to do is you would also have to divide this minus 1 by 2 as well. Remember, we have to be fair to all our terms. If we divide 2 from every term in our equation, remember we have to treat both sides of the equation equally. We have to do the same for every single term. You're lucky that wasn't the case, because then you have to deal with negative a half as a fraction. But just to be careful, okay, whenever you're canceling things inside the equation, you have to make sure every single term has that fraction, has that factor before you cancel it. Otherwise, you have to make sure you divide properly or multiply properly, whatever that is, okay? So moving on with this, with our example here, luckily we don't have that, so we just deal with this. So then we can now distribute the x inside our equation. X times 1, that's just equal to x. Sorry about the lag. So x times 1 is going to give us x. And then x times negative x, or minus here. Okay, so then I have x times x, so that's going to be x squared. That's going to give me x minus 3 on the other side of the equation. That's cool here because we have now x on both sides of the equation. I could just cancel it out because they're adding each other, but just to show you the steps, I'm going to divide minus x on both sides of the equation. Gets rid of this guy, gets rid of that guy. Very nice. Now I'm left with negative x squared is equal to negative 3. Again, don't forget about that negative in front of the 3. I have negatives on both sides of my equation. So that just means I can just make them both positive. Why? It's like multiplying -1 to both sides of my equation. If I multiply both -1s to both sides of my equation, I get rid of that negative. So I have x squared is equal to 3. Ooh, x squared. Ooh, so scary. It's just the opposite of square rooting. So what's square rooting? Just taking the radical, putting it over a radical sign, just like that. Okay, radical sign gets rid of my square. They're inverse operations. I have x is equal to square root of 3. Personally, I don't need you to evaluate that. Square root of 3 is perfectly fine. We can just leave it as that. If you want to really put it into your calculator, go ahead. What is that? That's going to be some very long number. 1.732. 1.732. So I don't care how you leave it. I have a stronger preference for you to leave it in a radical sign, and it's just like leaving your answer in your improper fractions, because improper fractions is something that's very functional. I can take that fraction and continue to do work with it if I need to. Things can cancel very easily on the top and the bottom of my fraction if I need to. I can't really do that with a mixed number, so I don't personally like mixed number for that sake. And same thing with a radical. If I have a radical with a 3 inside, and if I start to take this number and multiply, divide, and do all sorts of operations with it, it's possible I may be able to get rid of this radical without using the decimal. It's very easy to see the 3 instead of the whole trail of decimals, okay? So anyway, sorry, that's a side note. That's the answer to that question. So I just want to touch on one key concept that you must take away with you, and you will get better at it the more you practice. You're gonna make mistakes on this, and everybody does. You're not the only one. I have been there too, and that is forgetting to treat your terms fairly. So please treat your terms fairly. Distribute the damage to all your terms. Feel like a monster. Exactly. When you're doing algebra, feel like you're the monster. You gotta like punch every term, okay? That's kind of what I want you to feel. Once you've mastered that, you're going to be ahead of so many students, because it's such a common mistake. I see that in grade 11 physics. So if you can do that, you can do better than my grade 11 physics kids, okay? Good luck to you. Thank you for watching. Fat Mama Physics signing out.